Evaluating piecewise functions. So to evaluate a piecewise function, we have to look at the value that we're trying to evaluate and then the domain definitions, right, for the different subintervals. So we ask ourselves -2, does that fall into this subdomain or this subdomain? Is -2 less than 3 or is -2 greater than 3? -2 is clearly less than 3, so that means that we're going to use this portion of our function definition to evaluate this. So f of -2 is equal to 5 minus -2. Subtracting a negative makes this addition, so we would be plus there. F of 3. So f of 3. So 3, is that less than or equal to 3, or is it greater than 3? Now in this situation, this is strictly greater than. So because it's strictly greater than 3, 3 is not greater than 3, it equals 3. So again, we fall into that top definition there. So plugging into the top function, it's going to be 5 minus 3, which is 2. And then the last portion comes from f of 4.5. So 4.5 clearly is bigger than 3, so we're going to be evaluating 4.5 in that second portion of our function. So it's going to be 4.5 quantity squared plus 1. 4.5, that's the same as 9 halves. So 9 halves squared is 81 over 4. 81 over 4, that's 20 and a quarter, so that's 20.25 plus 1 is 21.25. And then that would be how you evaluate. So if you're trying to evaluate piecewise functions, basically you look at the input and figure out which part of your function definition, which interval it satisfies. Okay? In this portion, we want to write the equation of a piecewise function. And you can see here that we're trying to write it as as 3 different pieces. It looks like we could write this as 4 different lines, but I'm going to treat this middle portion as an absolute value. And so I can use it as a single function definition. So I'm going to do this graph first. So this portion of my graph here first. It's just a line. Where is it defined? So it's defined for x values in between -6 and -3. So in between -6 and -3 is the x. At -6, we have a closed point, so that's going to make this a less than or equal to sign. And then at -3, it's open, so that's going to leave this as just a less than sign. Now, because this is a linear equation, we need to find the slope. So up 2, right 1, up 2, right 1. So the slope is 2. Slope is 2. And if we want to put this in slope-intercept form, we need to find the y-intercept. And you could do this by writing like 2x plus b, plugging in x and y, and solving for b. But we could also just use the pattern of the slope to figure out the value of b. So I'm going to continue the slope pattern. So up 2, right 1, up 2, right 1, up 2, right 1, and see where it hits the y-axis. So it ends up crossing the y-axis at +7. So this would be y equals 2x plus 7. Okay. So let's go ahead and take a look at this middle portion here. So this middle portion is, I'm going to use a absolute value definition for this. So it goes in between -3 and +2. So -3 less than x less than 2. At -3, it's a closed point, so it's going to be less than or equal to. And then at +2, it's an open circle, so it's going to be strictly less than. Now, this curve has a slope of 1 and -1. So -1 here and 1 here. So it's just our normal absolute value. So it's just the absolute value of x. But it's been shifted up 1 unit. So that means we're going to just add 1 to our absolute value there. And then lastly, we have this function here. It's just this horizontal line. And horizontal lines are determined by an equation y equals some number. This is just y. So what is the number? Well, the number is just 5. So f of x equals 5 is going to give us that part of our graph. But for what x values? Well, it's for everything to the right of 2. So the way that we say that is we say that it's for x values that are greater than 2. And because the point is closed, it's going to be greater than or equal to 2.